Alright, in this lab we're going to look at colligative properties. And a colligative property is any property that changes based on how much solute you have dissolved in the solution. The interesting thing is it doesn't matter what the solute is. It doesn't matter what its molar mass is, doesn't matter what type it is. It only matters how much there is, how many particles get in the way of what it's trying to do. And the three properties we usually talk about that are affected by solute being dissolved are boiling point, freezing point, and vapor pressure. And we're going to focus on boiling point and freezing point. Alright, so what happens when we add salt to water? Well, we know if we put salt on the roads or salt in our driveway so that the water doesn't freeze. So what it's actually doing is lowering the freezing point. It's requiring more energy to pull away the heat so that the crystal will form. So we call that, because it's going down, we call that freezing point depression. And for boiling point, the boiling point rises when we add solute to it, which is why water boils at a higher temperature when we put salt in it. So because the boiling point is going up, we call that boiling point elevation. The salt or the solute gets in the way of the boiling occurring, requiring more energy for the boiling to occur, which is why the boiling point goes up. Alright, the equation for solving for boiling point, new freezing point depression or boiling point elevation is the change in temperature either at freezing or at boiling is some constant that applies for that substance. And we see the constants for water right here. This is the freezing point constant and the boiling point constant, times the molality, which we just talked about, times the dissociation constant. Both of these should be a small I. So the thing that's new to us is this dissociation factor. And what this means is how many particles a solute breaks up into. So we know if we have, let's say, magnesium chloride, when it breaks up into solution, we get 1 magnesium plus 2 chlorine minus 1. So this will break up, each one of these breaks up into 1 plus 2 or 3 ions. So this has an I equals 3. So if I just had, let's say, sodium chloride, it's going to break up into 1 sodium plus 1 chlorine minus 1. So that's going to give me an I equals to 2. So the magnesium chloride will lower my freezing point more or raise my boiling point more because it has a bigger I. Okay. If I have something that's not ionic, or that's a non-electrolyte, which means it's covalent, then it will not break up. So if I have, let's say, sugar or any kind of covalent compound, it will not decompose. It will not break up into ions. So I on anything covalent is going to be 1. Alright, so let's take a look at a couple of problems. On this first problem, we're trying to find the freezing point and boiling point elevation of a solution made from 25 grams of sodium chloride and 0.5 kilograms of water. So let's start with the equation for determining the change in the boiling point or freezing point. Okay. Alright, so what we want to know, we know the change in temperature at freezing is this K sub F times molality, and you will get these constants, and you will even get this equation times the dissociation constant. So K sub F we know is 1.86. Molality is, it's not given to us directly, so we're going to have to calculate. It's moles over kilograms of solvent. We know kilograms is 0.5, right? 0.50. Moles, we've got to figure out 25 grams of sodium chloride. Each one is 58.44 grams, is 1 mole. So this is going to give us 0.428 moles of sodium chloride. Put that here. If I divide these, I get 0.86 molar. I got 2 sig figs up here, right? 0.86 molar. So I'm going to apply that here. 0.86 molal. And I, sodium chloride, is going to break up into 2 ions, so my I will be 2. So if I multiply that out, I'm going to end up with 3.18. So that's how much the freezing point changed. But if I wanted to know what is the new freezing point, what I have to do is recognize that normally water freezes at 0. This you need to know. It normally freezes at 0. It's going to be depressed, so the freezing point is going to go down by 3.18 degrees C. So my new freezing point is equal to minus 3.18 degrees C. Okay? Now I can do the same thing for boiling point by changing my K sub F to my K sub B, right? Which is going to be 0.52 instead of 1.86, right? My molality is still the same. My I is still the same, right? So this is going to give me a different answer. And what I'm going to do when I get my answer is I'm going to say normal boiling point is 100 degrees C. I'm going to add whatever change I get temperature at boiling to that to end up with something over 100, plus, whatever that is, degrees C. Okay, I'll let you figure that out. Alright, let's take a look at another problem. Here we have 5 grams of a non-electrolyte added to 25 grams of water. The new freezing point is minus 2.5, and the question is, what is the molar mass? Okay, so the change in temperature at freezing is the equation we want to use. So change in temperature at freezing is equal to K sub F times molality times I. Okay, I know the change in temperature at freezing is 2.5 because it's normally 0 and it went down by 2.5, so it's 2.5 is equal to my K sub F, which is I get from my constants, 1.86. I don't know my molality, so I'm going to have to figure that out, times my I. And my I here, it's a non-electrolyte, which means it's covalent. It will not dissociate, so my I is 1. Okay, so if I want to solve for molality, I'm going to divide both sides by 1.86, and I get that my molality is 1.344. Okay, so now I need to figure out what my number of grams, or what my molar mass is. Okay, so molality is moles over kilograms of solvent. Okay, so in order to get molar mass, I need to first get moles. So what we see here is molality times kilograms could be moles. So moles equals molality times kilograms. My molality is 1.344. My kilograms, let me see, the given is 25 grams here, so that's 0.025 kilograms. And if I multiply that out, I'm just going to pause for a second. Alright, so let's come back to this. Alright, so what we said was, I accidentally erased what I had there, but that's okay because I'm sure you've got it written down. Let me get my pointer options up. Okay. Or you can rewind to get it back. Okay, so what we left with is we have 1.344 molal solution, right? And that molality is moles over kilograms, right? And the kilograms is right here, 0.025. So moles is going to be this times this, which is going to be 0.0336. Okay. Now it's not asking for moles, it's asking for the molar mass. So we know that moles is equal to however many grams we have divided by its molar mass. So let's rearrange this equation because we want to solve for this. So moles times molar mass is equal to grams, right? This times this equals this times this invisible 1, right? So if I want to solve for molar mass, I'm going to divide both sides by moles. So my molar mass is grams per mole. Makes sense, those are the units. So it's going to be 5.0 grams over 0.0336 moles, and that's going to give me 150 grams per mole when I have just 2 sig figs. Okay, and that's going to do it.